So question 2, given the heat equations, del U del T equal to del 2U del X2, where the X came from 0 to 1, T from T positive with the boundary condition U0 T equal to 0, U1 T equal to 5. And then the initial condition is Ux0 equal to 5x for x0 to 1. Solve the heat equation by taking delta x equal to h equal to 0.1 and delta t equal to 0.001 until t equal to 0.002 by using the explicit implicit this Wednesday we're going to look at the implicit finite difference method. Okay, so first step, we go to draw the grids. I will put it to Excel because it's neatly it is neat compared to I draw the table. Okay, so T up to 0.002, delta X is 0.1. Let's say this. Okay, you may put up, I think they might put up, the H is 0.1, K 0.0001, and the C squared is from the coefficient of del 2u del x2. Okay, hold on. Where is it? So coefficient of del 2u del x2, C squared is actually 1. H is 0.1, K is 0.0001. Okay, then you may calculate the R, which is K multiply C squared divided by H squared. Okay, and then the 1 minus 2R is equal to 1 minus 2 times the R value. Okay, that's why your molecule top is 1, left bottom coefficient is actually equal to your R, which is 0.01. Okay, the center bottom coefficient is 1 minus 2R. Okay, the right bottom cell is equal to R. Okay, this is a molecule for the explicit scheme to solve the heat equations. Okay, and then you may draw the grids T 2 or 3. Let me see. 2. This 0. So x0, h is 0.1 up to 1, x0 to 1. May it centralize. Then you just drag it up to 1, and then put out the boundary condition. U0t is the left boundary conditions. Okay, let's say I put out here. Okay, mean when x0 u are equal to 0. So I can equal 0, copy it down. Okay, these are the grids. Okay, and the right boundary u1 t equal to 5 mean when x equal to 1, u equal to 5. So equal 5, may type equal 5, and then you just copy it down. Okay, later on the initial conditions. Okay, initial condition is when t0 u is equal to 5x. Okay, you can here 5 times x here. So you see whether the boundary and the initial condition overlap or not. Okay, 5. So overlap. Okay. So we have filled up the boundary, left boundary, which is 0, right boundary, which is 5. Initial condition is ux0 equal to 5x, means 5 times of the x value. Okay, after that, okay, using the molecule here, mean the cell that you target, this one, this targeted cell is actually 0.01 times your left bottom here, plus 0.98 times this case center bottom. Mean when you apply the molecule this way, it's actually this cell equal to, if you take the cell here, make sure you constant it because this is a constant value. Okay, the coefficient of the left bottom multiply the left bottom cell value plus, okay, the center bottom coefficient, which is 1 minus 2r, multiply sorry, wrong place, equal this time here. Okay, the r make sure constant plus, this is 1 minus 2r, make sure constant it, multiply center bottom cell plus, okay, this is r, okay, make sure you constant it, okay, multiply the right bottom cell. Okay, and then let's say you can copy it down up. So this is a solution. Okay, all are same. Let me check question number 2. Yeah, number 2. So within a few minutes only, you obtain a solution for question 2 using explicit finite difference method for solving the heat equations.